Working? Great. Well, thank you. I'm very excited to be here, and you're going to have to get used to my face because I'm going to be tomorrow in Jamie's spot talking to all of you and presenting. So before I even start talking about my presentation, maybe I can give you a little bit of personal traits so you can connect with me. Renata with the rolling R because I'm South American. I'm from Chile and Brazil too. It's complicated. And I really like dogs. So you're going to see some pictures of dogs. But now that I broke the ice with you guys, I'm going to be talking about training data, right? But the biggest part of it is how important your training data is to ensure that you have good quality. And if you don't have that good quality, how that can be veering you off course. And that's a catchy title because it's funny, but maybe not for everyone. But either way, the first thing that I'm going to be talking about is going to be noise and what you should be doing about it. What can you do? What you cannot do about the noise? I'm going to be giving you an overview of how being the right quality strategy and how that can help you ensuring that you don't get the noise that you don't want in your data. I'm going to be going over tips and tricks to optimize your process to ensure that you have the right quality data that you actually need for your model. And quick overview about Tama, and finalize everything with key takeaways so you get all that information fresh in your brain when you leave. And then you can go and ask me questions about it afterwards. So let's start with noise and what to do about it. So noise is everywhere. Noise is a typo in this presentation. Noise is me making up some stuff or like saying things that I shouldn't have said. I'm really good at swapping words. Sometimes I want to say green, well, you see. I want to say green, but I say blue. But sometimes you can get some context, right? So if I'm talking about the neighbor's grass and I say blue, you understand that I actually meant to say green, right? But sometimes that noise is very, very hard to avoid. So there's 3 different types of noise that I'm going to be talking about right now. The first one is human mistake. And with large data sets that deep learning models really need, it's impossible to guarantee an error-free data set. If someone tells you otherwise, they're lying. Because data annotation or like ensuring that you have the right ground truth information, it still requires manual process. Even if it's someone checking and ensuring that the data is right, someone might have checked wrongly. So there's no way that you can avoid the human mistake out of it. The second one is subjective ground truth. Some cases are impossible to define. So if you think about a car going through and roading like at night, and you have the 2D images, it's impossible for you to properly define the tire, right? It's dark. How can you know where the tire is? So you do have to do some subjective thinking in there and think, yeah, the tires are this shape, so I'm going to try to guess where those tires are. Then the third one will be sensor data accuracy, and my least favorite one, because it brings a lot of issues, especially when you're dealing with annotation and ensuring that the data is properly done. You can think about low resolution cameras, localization accuracy, my worst nightmare. I actually have quite some questions for the cruise guys afterwards around that. Camera calibration issues, occlusion, and all of those are examples of imperfections that are limiting the accuracy of the data that you get. So I always question everyone and myself, like how really perfect quality do you need if you have all those different like elements that are going to keep on bringing the noise? But the good thing is that your model doesn't need perfection. As you are able to identify that I said blue, but I actually meant to say green, there are certain signals and contexts that we as humans, we know how to identify. Deep learning algorithms are actually really good at identifying these signals and knowing what noise is noise versus what signals are actually things that they should be listening to. So what are the examples of noise that actually can hurt your model? These are the ones that you do not want your data to have, because otherwise you're in trouble. And the first one, it's a critical high level of noise in your data, the one that everybody knows about, 95% confidence, yada, yada. Deep learning algorithms, like models, are really good at ignoring this level of noise as long as there are not too many of them, because they can learn a signal. If there are too many of them, they're not going to be able to learn the signal. So in this case, I have 4 different tasks. One has a missing object or completely out object. The other one is perfectly annotated. The other one is like 99% because it cuts a little bit the other object, and the other one 95, let's say. In average, this is more than 95%. It's 96%. So in a batch level, you're good. The model should be able to learn the signal and all that. If you go under 95, then this would mean that maybe your model will will have some problems with it. The second one, and this is my favorite, especially in this time of the year, because I can give an example that it's pertinent, is particularly noisy slices or segments. So in Detroit, probably as well as in Montreal. I live in Montreal. That's why I said it's complicated. I'm all over the place. When you get snow, motorcycles cannot go out. So there is a specific date where they have to stop riding, which is very sad for all the guys that love motorcycling, and girls too. There are a lot of girls who likes it. But imagine you start collecting right the day before, or like the same day that like the last day that they are allowed to go out. In that case, your data set might be more than 95% quality, yay. But if you look deeper into that particular slice or segment, you might be at 50% because you don't have enough data to actually have it. So it is important for you to understand that like the segments and slicer data also needs to have this 95% quality requirement. Then the third one, these dogs are alive, they're sleeping. I've got people telling me that they look like something different, so I want to just assure you they're safe, they're good, and I love dogs, so no worries. If I were to ask you, what is the direction of travel of these 2 beautiful dogs? Would you be able to answer that? No. Imagine all this room trying to do the same annotation. It's very easy to fall into the consistent noise or like systematic errors trap, where if you do not define the instructions properly, you can get that, right? In this case, there's no direction of travel, they're sleeping. So like just mark it as like, no, they're not moving, it's fine. That needs to be defined in the instructions and the quality rubric. So if these errors are in your data set and they form a pattern, then it's going to be hard to replicate, and that's when that type of noise you cannot afford. 2 people with the same information should be able to score this the same way. And right now I'm only showing you 2 dogs. It's easy, but imagine a 3D world, and I see a lot of nodding, a 3D world where you have a lot of information and a lot of different edge cases, and that's why edge cases are so complicated, right? So that would be the third one. So now that we talk about at least like those 3 important noise that you have to be aware of, how can you ensure to have the right quality strategy? There's going to be 3 different things that I'm going to be talking now. The first one, and when I say like quality strategy and robust quality rubric, like these are kind of like similar elements. The quality rubric is more like how do you organize your whole strategy in one place so everyone can score the data the same exact way. But there's 3 different elements that you should be aware of. 1, like you have to ensure that you have the right expertise. 2, you have to make sure that your instructions and trainings are perfect. And if they're not, that you have the process to make them better. And 3rd, you have to ensure that you have the error types and the scores that you want to penalize these errors. So I'm going to dive deep into each of them. The first one, you have to get the right expertise. A 3D world, as I said, is extremely complicated. add to that if you're loading a LiDAR, or you want to do the annotation in LiDAR, and you want to mix that with 2D images, and you want to add, I don't know, ultrasonic data in there. Like, there's so much complexity that is particular to those type of, like that type of annotation. The first being like geospatial awareness. Not everyone is good at like this like 3D world. Like, I am really good at fitting objects in a door that are not supposed to go in. And I guess that's why I work in 3D annotation. And I just realized that I didn't say what I do. Well, I'm going to talk about that at the end, but I build a platform that allows you to annotate and validate and everything in 3D. So, of course, I have to be good at geospatial awareness. The second one is point cloud know-how. It's not only about understanding how to interpret all those points, but it's also about knowing how to interpret those particular sensors that you're annotating, because they all look very different. And it's hard. Some of them are really, really hard to know and understand and interpret. Other ones are a little bit easier, but still you have to learn that part. And the last one is having a detailed-oriented process. It's not an easy task to annotate a full world that is happening outside, full of different agents moving around, and it's very, very, very complex. And if you think about it, like if you get a task, like think that you have like a 3D world, and you have also 2D images. You have to annotate all the cars, all the pedestrians, all the traffic signs, all the lane marking, everything in there, you have to annotate it. Guess how long it's going to take you if you have it to do it manually, or even if you have to correct it. The time that it's going to take you to review everything, if you have a sequence of, I don't know, 100 to 700 frames, 1,000 frames, you really need a detailed-oriented process and people that will be able to follow that process to ensure that you don't have the human mistake, or that at least you don't have enough of it for it to become a problem. The second one, we talked about it. You need to create great instructions and training. The key here is to ensuring that two people with the same information should score the annotation the exact same way. And if you have a world that you have to interpret and know and like identify edge cases, you have to make sure that this is right. And you have to make sure that you have a process to identify when something is different. Because if, for instance, you have an edge case, you have someone that's like, oh, what am I supposed to do with this case? And nobody says anything about it, or nobody flags it and talks like back to like the ML developer to like ask them, how should we treat this case? Then that's going to fall into the inconsistency of the data and not good, right? So you have to ensure that you have the process to at least like be able to bubble up all these edge cases as they go and give that back to the ML researcher. Then 3, and this is one of my favorite slides because I go like very close to what are actually some error types and penalties that you should be thinking of. You have to have a good structured quality rubric so you can spot these errors and you can penalize them. And some examples of those will be obvious ones: incorrect labels. You annotate a child as a person, but they are two different actors that behave completely different. So that's quite, imagine the child is actually in a skateboard or something like that. That wouldn't be good. You can have missed objects. So there's a car that is far away and you cannot see the points very properly, so you just missed it. Then you have missed points. Think that you have a cuboid in a 3D world, and you have to like annotate all the points inside. Sometimes you will have some points that pop outside or come inside, etc. And I think that matches perfectly with the object size error too. Sometimes you're annotating, you have to identify a truck, right? You see a truck in 2D, but because the points are very like small, you think that that's maybe a sedan or something much smaller than it actually is. So you have to ensure that you have the right tools so you can see the object tracking and see that object and have the 3D to 2D kind of like projections to ensure that you can identify that object as well. Then you have object tracking issues. This is a classical one where like the object leaves the scene or like leaves the field of view and then it comes back. but then the tracking ID is not the same, or sometimes you have to kind of cut the sequences, and you'll have like two IDs that will be separated. Those are things that you have to also be aware of. Bloom and reflection is a typical, where you have like the points that are like fakely in there as bloom, and you have to be able to identify those. Too tight, too loose. So if the cuboid is too tight or too loose, depending on your quality requirements, remember the errors that I was telling you about sensor accuracy. Sometimes you don't need them to be perfectly fitted, and also depending on your use case. Are you like building a model like at the beginning, or are you just like validating that your things are working properly? Or are you using LiDAR to annotate radar, right? Like you want to use LiDAR to have a reference, but then you have the radar data that is not necessarily that perfect, so you might not need that much fitness in a cuboid. Incorrect direction of travel. All of you probably got that wrong if I didn't tell you how to annotate that. Alignment errors will be the typical one where when you're doing 3D annotation, you have a cuboid and the cuboid is moving, right? Sometimes you're only seeing one frame and you're not really seeing the track of that cuboid. And you have to ensure that the pose is right. So if the cuboid is like this, and sometimes like you don't have enough like visuals in the points, you would see the cuboid moving like that. So it would kind of like be jittering, but actually the object is not jittering. So you can like ensure that you have the process, like the right tools that will allow you to identify these alignment errors, because you don't want that data to be ugly, depending on what you need and how you need that data to be. And then jittering also, like sometimes you'll have like cuboids that will be like moving around like up and down if you don't have like the right tools to ensure that it's glued to the ground, etc. Okay, so now that I went through all this error types, hopefully they were useful for you. When do you need to have a quality rubric? My suggestion is for you to think about this from the beginning. So always have it for yourself. From exploratory research up until edge case management, you have to ensure that you have like a standardized process to ensure and like that you don't introduce any noise into your data set. Now that we went through the whole what is noise, how to define the right quality strategy, let me give you some tips and tricks to optimize the process based on like my experience working in this side of the fence for the last few years. And the first thing is to be hands-on, save time and money. I'm going to swap the cards. So first, experiment with your labeling process. That's going to give you everything that you need to identify all the issues in a much speedier way. So from the beginning, put yourself in the shoes of someone that is really trying to identify all the information that you need for your models. That will allow you to identify sensor quality issues that might like speed up the process or like might reduce a little bit like the noise that you have in there. Identify edge cases from the beginning, and it is important for you to experiment that with a strong annotation platform. You can start with open source stuff, and then you can move towards something a little bit more fancier for your use cases. And then the second one is think about time versus quality. You should be reducing scope at the beginning so you can get that iteration going, maybe reduce the ontology size, the label attributes. Sometimes if you're doing object tracking, you don't necessarily need all those like dynamic information from the batch. So you start small and then you keep on increasing and even experiment with label accuracy. Annotation accuracy sometimes is not needed, so like that perfect fitting cuboid might not be needed, and you can experiment with that. And then afterwards, you can keep on adding and adding to it. So who should annotate your data? As I said, be hands-on, so you should do it. Kidding. You do not have to do it the whole time. Like, do it at least at the beginning so you identify all this and you know how to communicate with whoever is annotating your data at the end. And with annotation, I mean, it could be from like scratch, or it could be validating the data that you have. At the end, you might want to have someone to help you. And you have to ensure that that someone will be able to have everyone in this room annotate the data the exact same way. And that's not an easy task to do. Okay, so I'm done with the fun content. Let me give you a little bit about Sama. There's 4 cards in here. I'm only going to be focusing on 2, which is quality and ethical AI, my 2 favorites. The first one is about quality and a little bit about like why Sama is really good at delivering quality. We've been working for quite some time in defining all this process and ensuring that you have the right data for your models. We have a specialized agent training, and on the next slide, you're going to understand why we're so good at that. But the other things that we do have is that we have strong tools to ensure that we have good quality as well. So we have auto QA that you can define project by project, like scripting, and really ensuring that that's kind of like that first level of like cleaning up and ensuring that you're not getting introduced. Then you also have like an internal QA sampling technique where we're allowed to review and fix things. So there's kind of like this like last man reviewing that data or last woman reviewing the data. And then at the end, you have like the client or the user sampling. So there's a lot of layers in there to ensure that you don't have that like much noise that will like remove you from the 95 and like put you down to something lower than that. And then this one is the reason why I'm here, is that we are an ethical AI supply chain. And the company started with that mission, and it evolved into what it is today to support that mission. We have impacted more than 59,000 people since 2008, and they are so grateful and so kind of like working. And I will tell you, I'm talking about quality and like how you don't need that much quality. It is hard to get them to do less quality than what they require because they are really hard workers and they are very detail-oriented, and I've been there with them, and it's just beautiful, and the reason why I'm here too. We are built for impact. And we're trusted by the world's most innovative companies. We've been here for a while. We've been working a lot, and we've been advancing with them because it is needed that we have the cutting-edge technology, and that's why I'm here. I got hired to build the 3D annotation platform and the 3D like validation platform and all that. So it's pretty exciting to be here. And I'm going to wrap it up. Key takeaways, and then open for questions. So the first one will be noises everywhere. You have to make sure that you know how to treat the noise and have the right strategies and quality strategies to ensure that the wrong noise do not get to your training data. Start small, experiment with the process, and be effective at what you do and how you do it. And then leverage a third-party tool or a third-party service like Sama Pro to scale without compromising on that quality. And that's it. Thank you.
Thank you, Renata.
Ah, that's a really good rolling.
It's better than Renata. Yeah,
yes.
Okay. Perfect. So, any questions that people would like to ask? No? Come on up.
Hello, I'm Ramin. I'm with Ford Motor Company. I have a question about privacy issues. When it comes to collecting data and labeling data, privacy is sometimes a concern for all the people that are inside, in that data. Do you provide any solutions for that? For example, blurring people faces or vehicle licenses or like tags or something like that?
No, we do not do blurring. We do ask for our customers to provide the data that is already well treated, right? But we do also take very seriously everything that is privacy, and we do have very much secure space. It's one of the cards that I didn't talk about because I didn't have the time, but we can talk about the whole concept of security both in our tech stack and our physical spaces, because as you see, there could be a room of this working in a particular project that is a very big project, then you have to ensure that also the spaces are well secured. So I can talk about that afterwards as well.
Sure, thank you.
Cool.
Awesome. So I'm going to build on that concept, and we can invite anyone else up to ask a question. So companies are spending a lot of money capturing road data. It's an expensive endeavor, big fleets of vehicles driving around, high-end data logging systems, and I can talk about that during the break. So how do you guys ensure the security of the data itself? So if I'm a company and I say, hey, here's my road data, help me annotate it, how do they know that you're not letting it get into their competitors' hands or someone else's hands?
Oh, yes, that's a really good question. Well, as I said, security is the most important, especially when you're talking about this type of data that can be very specific. We ourselves also build our own models, so make things more efficient, etc. But everything is customer specific. We do not move any data from one customer to another customer. We do not use the data from different customers to build our own models. We actually do have a concept of micro models where we have a general model that is built on generic data, and then we specialize that model to that specific customer so that we can get a better turn and throughput, because of course labeling is very hard effort. So we usually work with our customers to get the data that they have from their model. So we use pre-annotated data to do validation. We give them back not only the data that is correct, but also insights on what and where they have to focus in their model so they can do more of an active learning, more speedy model development. And I think the most important part in there is that we stick to what our customers have, and we do not mix anything in between. And of course, we have everything that is needed for a secure environment so that data doesn't flow anywhere else.
Thank you. You'll bring us home here.
I had a question about your kind of model in the loop stuff you're talking about, annotating with a model prediction.
Yeah.
How do you guys handle confirmation bias that can come up from being presented with a prediction as opposed to a blank scene?
So there's different and there's another talk that I love giving about how do you use humans, or how do you introduce AI into humans when they're within the process and they're using the predictions itself to do the work. I think that's light of people that are the quality that is required in the process to ensure that the quality is in there is pretty important. So if they look at the data and there's something wrong, in a way, they're not going to be following yeah, sure, this is fine, or this is the right way of doing things. No, they're going to go back to the quality rubric and ensuring that the data is labeled the exact same way as it is defined. So we see a lot where the data is not properly done, where they would just scratch it. It's okay, no, this is so bad that I'm just not delete, because we want that information. So we do have a feature that allows you to just start over. You keep the ID, you know that information, so we can then give that back to the customer. But they would just rework it from scratch whenever it's something that is different from what is within the quality rubric. Yeah.
All right. Thank you. Thank you very much. Great talk.
My pleasure.
Excellent.